and welcome to coroutine testing workshop. There is no presentation, there will be just code. So if you have your computer with you, clone this repository so you could follow along. Okay, you have computer? Someone else? Okay, nice. So this is a very simple application which fetches some data from the API. Just the usual stuff. We do it every day, okay? But there's a catch. We are doing it in Jetpack Compose. So how does it look like? We have this main activity, nav container, some animated nav host even, and two screens, details screen and list screen. Let's take a look at list screen. News list screen. Okay, and what's happening here? We have some kind of view model defined with coin. I can show you the coin dependencies, some single modules for in-memory database, use case, second use case, some data source, error mapper, some other mapper, and our view models. View model responsible for fetching and displaying list on the screen, and view model responsible for displaying details. So let's take a look at this list screen. We have view model with state flow. Okay, I don't like this notation so much, but it can stay that way. We have mutable state flow exposed as state flow. And this state is collected inside composable functions, and we are rendering everything in here. Okay, we're not going to be running the whole app. We will take a look at domain layer, data layer, and wonder how we can unit test this stuff. Additionally, I added useful test libraries in build Gradle, implementation. Okay, we have JUnit 5 defined here. We have Kotest, we have MockK, we even have Turbine, which is library to test flows, and additionally mock web server. Okay. So our view model has a dependency, some use case, and some mapper, and some other use case, which is just dummy use case, always returning the same query. Okay, let's take a look at this use case. Use case has as a dependency some retrofit API, some kind of mapper, and some kind of in-memory database. Let's take a look at that. It's just bugged by hash map internally. We have some article entity and string representing ID of that article. So, very simple implementation of in-memory database. Okay, and in our use case, we are doing few things. For the starters, we are asking retrofit API to fetch data by this query. We are mapping articles with that provided mapper, and we are also updating in-memory database. This database will be useful later to fetch item by ID. Okay, let's take a look at retrofit. It is implemented with OK HTTP, and additionally we have some error mapping here. This is all in the repository that you can find here on my website. This is the link from yesterday's presentation, and this is the repository we are working on under this link. If you want to configure this whole project, you probably additionally need to create secrets.gradle file to have this news API keys in your project. There is example provided So you can just copy-paste it and remove .example. Okay, so what should we do first? Let's create unit test for mapper, for boring mapper. So what am I doing here? I'm clicking create test, option enter, create test, enter, enter. Yes, add to Git. Okay, let's remove all that stuff and implement this test with Kotest, with string spec. How many of you already know Kotest? Okay, nice. And how many of you uses JUnit style tests? Okay, most of you. So in JUnit, we create test by providing annotation. Test annotation from JUnit 5. Some test, and this is our test case. This is test class, this is test case. But with Kotest, we are the whole test class, the whole test specification, we can say, extends some kind of specification provided by Kotest. So in that case, we have string spec, and that means that our test cases are defined by strings. This is the first test, and check open lambda. This is second test. Nice. Let's remove this, and I will show you how to run. How to run it. Probably you need to add a plugin for your Android Studio. Plugin responsible for managing this Kotest test. I have already installed it. I have this installed, but you should probably add this Kotest plugin just to have these green triangles inside your Android Studio. I think that in IntelliJ, Kotest plugin is loaded by default. Okay, tests are running, and how does it look like? Just like regular JUnit test report. So we have this domain and test name, first test, second test. Okay, those are just regular test cases defined with string. But we have other specs available. For example, free spec. Free spec, with free spec, we can nest test cases. We can create test group. And with this, in this style, we can create nested test cases. Okay? So test group minus, this is actually operator function for defining DSL, minus another lambda, and inside this lambda, we have other tests. And in the JUnit report, we have this test group. Okay. So this is how we define string spec, free spec in Kotest. But we don't want to test only some dummy stuff. We want to actually test our mapper. So how can we do that? We have this article entity mapper. This is our system under test. Okay, I will name it just mapper. Mapper maps some kind of article DTO. Fake article DTOs with count 1 first. In this repository, I created already fake test data. So there is fake articles.kt that will generate article DTOs and article entities. Okay, but for the sake of this example, we can just copy paste first article given DTO equals this, title first, source first. And we are passing this given DTO to our article. So given DTO, actual entity. Okay, we need to put everything in test. And yeah, what is happening here? We are creating our system under test, which is mapper. There are no dependencies. We have our given DTO, so the article we are mapping to our actual entity, to our article entity. Let's specify type explicitly. Next nice thing in Kotest, we can do assertion like this. Article entity should be. In JUnit style, you would search for assertions, assertion.assert equals, things like that. Actual, expected. Okay? But with Kotest, you can actually use this domain-specific language, infix function should be. So, actual should be what? Article entity mapped to this entity. Okay, let's copy paste it from here. Fake articles. Copy paste because I am so lazy. We are expecting something like that. Source first, title first, published at, and link to article first. Okay, no image, no description. So actual should be expected. Let's run this test. And it failed. Why? With this Kotest assertion, we have actually comparing two data classes. That's like assertion for equals, okay? And because there are data classes are equal when their contents are equal. So we have difference in here with published at property. So let's change this expected to other instant. Can we do it like that? Yeah, we can. Please repeat louder. I am adjusting test cases because I copy-paste this from my other mocks. Okay, now this test passed, but we can do something with our system under test. In here. So we can verify if our test will be failing if we do something harmful to our system under test. Okay? So we can change here this instant to something like distant future. And now our test should catch that. And it actually catched that. Okay, let's Control Z, that stuff. And okay, this is comparing the whole data class to the other data class. But actually, we have some method, assert softly, to easily compare only selected properties. So actual entity.author should be expected article entity author, for example. And why are we doing here assert softly? Because when the first assertion in the test case fails, the whole test fails. But assert softly under the hood is collecting all the assertion errors that were thrown in that particular test. So now we can have many assertions here, for example, for author, for URL, and title should be author. Okay, let's do something like that. So we expect that this assertion will fail. And it actually failed. Okay. We can do something else in here. The second assertion would be that URL to image should be something like that. And we know that this URL to image is null. Okay, so now we are testing our test behavior. Without assert softly, what do we have in here? We have only information about first assertion that failed. And this code, this assertion, URL to image, wasn't even executed. Because once this assertion failed, the whole test failed. But with assert softly, we are collecting those assertion errors. And now in our test report, there will be assertion failed for author and assertion failed for this image. So this is quite a nice tool. You can compare the whole objects. And if you want to have many assertions in one test, you can use things like assert softly. In JUnit 5, there is also a similar mechanism, but there is much more boilerplate. Okay, let's fix this test. Title, there should be null, or we can say expected article entity. URL to image. Let's run this again, and we can go to the next class, next test. Okay, it's green. Or do you have any questions to that part? Defining tests with string spec and doing assertions with should be. You are suggesting that we should do what with should be?
No, I'm asking if it has relation with Fluent.
Fluent? No. Fluent is separate third-party library. Kotest is library maintained by JetBrains. So if you are loading Kotest to your project, you have runner artifact for defining test cases with strings, funspec, stuff like that, and you have assertions for defining assertions with should be something else, stuff like that. But yeah, Fluent, strict, there are also other nice libraries to do the same. But I'm using Kotest most of the time. Okay. We created test with Kotest for this article DTO to entity mapper. Now we have some more interesting case. We have our fetch news use case. So let's try to create test for that. Again, let's remove this. And now we will use behavior spec. And this is actually a pretty nice thing because it allows us to group our test cases with given, when, then structure. First, I will show you how it looks like. Given, when, then, and actually we can have many then, many then blocks. So this is first. This will be second. Let's run this whole class and see how our report looks like. So we have our test class and test group. Given something, when, then. When B, then A, B, C. So you can do this with behavior spec. OK. So let's try to define our test cases for this fetch news use case. It is suspend fun. It is fetching data from news API. It is mapping something, and it is updating in-memory database. What test cases should we do? Any ideas? We can create test case for the happy path. So for example, given data in API exists when, or maybe something else, given query equals Tesla, when articles in DB exists, then return articles entities. OK. So this will be our first test case. So now we need to create dependencies for our system under test. We have news API, we have mapper, we have in-memory database. I will create helper function for it, create use case, and we'll OK. It should be bigger, I think. Create use case, and we'll provide default arguments in here. OK, create use case. It should return fetch news use case. Change return type, and we have news API. News API. We have mapper. We will use real implementation of that mapper. And in-memory database, we will pass that. OK, so we have news API of type news API. We have our in-memory database. Do we have interface for that? We don't have interface, but that's OK. OK, so we have a way to create system under test. Create use case equals create use case. Let's make this smaller. Create use case, and now we are defining our news API. This API is defined by an interface. So we can use MockK, or we can use anonymous class. News API, if query Tesla, we will return fake article DTOs 10 article details, I think. Okay, we need to wrap this also in news response. Status equals OK. Total results equals 10. And articles equals it. So we created actually fake for dependency for our system under test. We can create it by implementing interface, by creating fake class. From here, we can convert this object literal to class. So let's extract it, and let's call it fake news API. And for that query, it is always returning 10 articles. Okay, next thing, our in-memory database. Database equals in-memory database. We'll actually use that later. Articles in API exists. Sorry. Okay, so we created our use case, given query equals Tesla. Some database is some database. We've got this fake news API. And we have database. So now we are invoking our system under test, fetch data, Tesla. Article entity list. Article entity list, for example, should not be empty. We have assertion of that kind in Kotest. Let's run this test. Else case? Oh, okay, okay. You're right. Not implemented. Thank you. Test event not received. Why? Yeah, I'm running. Okay. Why is that? Okay, because I was running tests from history with some weird configuration, so we need to fetch this test configuration again. There was something in memory. Okay, so we have our test case. Given query equals Tesla, when articles exist, then return articles entity. We can change that to return non-empty list, for example. Okay. And did you notice that we didn't have any problem with calling coroutine from here? This retrofit API is suspend function. And also, this fetch news use case is also suspend function. And this is suspend function call. And we can do that because Kotest spec has already inside some coroutine context. Probably we shouldn't use directly that context for more complex calls, but if we want to just load some coroutine-backed code, even query here, that should be fine, just for calling simple suspend functions. Okay, what's the second path in our use case? We are checking if this database was updated. So let's write a second. Then update data in database. Let's lift this to when. And now, database. What do we have in database? In-memory database. Okay, in our public API of this in-memory database, we don't have any getAll method. We have only update, and we have find by ID. This is public API of that class. And in general, we shouldn't change so much any real implementation just for the sake of test. If we are not using any getAll method in our production code, let's not create that method only to create unit test. So without modifying this in-memory database, we can do mock with MockK. So let's not use real implementation, but let's create mock with mocking framework. So this equals to in-memory database. With configuration relaxed equals true. Okay, let's run this test again. Oh yeah, engine exception. Let's run this again. Okay. Let's run again and see what happens on the second run. It worked. Okay. Do you know why this test passed? Because we have no assertion here. So we should do some kind of assertion, and now our assertion will be on that particular mock. We will check if that method was invoked. So with MockK, we write verify in-memory database, or just database, update with any. Okay, but we don't trust assertion frameworks. So let's test if this test is actually working. We'll try to do other assertion. That will check if this was called exactly once. In Mockito, you will say that verify never something happened. But with MockK, you pass this as exactly 0 times. Let's run this again and see if our test fails. Okay, it failed. So it looks like our tests are working. Let's change for a minute implementation. Let's comment this out. Now we are checking if our tests actually catches some errors made in production code. Okay, so I guess it's working. So, given some query, when an article exists, then return non-empty list, then update data in database. Our test looks like this. What's coming inside this query Tesla, and what's coming out, and what is returning. So it is returning those article entity list, and we are doing assertion that it should not be empty. Let's change it to should be empty to verify if our test is working. And yeah, test is working. So it can stay that way. Okay. We can now try to refactor our fake news API from this fake class to MockK. So let's do that. Where is our fake news API defined? In here. So let's refactor it somewhere in here. Okay, and I will say it equals MockK of type news API. And now I will actually create behavior for this mock. So MockK news API. And I will say that on every function call, get by Tesla, it should return something. What it should return? Fake articles wrapped in news response DTO. Okay, but why it's not working? Because this function, getBy, is actually suspend function. And for suspend functions in MockK, we have CO every. CO like coroutine. I don't know, co every, CO every, not sure. Okay, so now we can return fake article DTOs, 10 articles. Let news response DTO, status OK, total results 10, and articles it. So let's run this test. And it looks like test is passing. So what happened here? We created mock instance. This is of type news API, specified type explicitly, with MockK. And with CO every function, we defined behavior for this mock. So on every getBy query Tesla invocation, it returns fake article DTOs. It's very similar behavior to what we did with this fake news API. Okay, so should you use that kind of fake, or maybe should you use MockK for mocking that stuff? Well, it depends on your coding style. Generally, you shouldn't depend too much on mocking framework, but if you want to, eventually, for some configurations, you will end up with many if-else, if something, then do something else. Or maybe if query equals Twitter, something like that, then throw error, return some other articles. Or maybe you can do something like that with, I'm not sure if for retrofit interface we can actually create fun interface. So we could create this in that way. News API fun equals news API. So with fun interface, you could actually do something like that. Fake articles 10. But again, you shouldn't change your production code adding fun to this interface just to have better tests. So you need to find a balance. What should be modified, what should be kept. Okay, let's remove this. So in general, for that, that kind of mocking, I prefer MockK now. Additionally, if you are using Mockito, coroutine support is not provided out of the box. You need to use, I believe, do answer methods. There are no straightforward mocks for suspend functions. Okay, again, what happened here? We created news API, coEvery, we can remove this parameter from here. coEvery returns some fake articles. Fake articles, status OK, total results 10, articles, so on, so on, so on. So we have mock for database, and we have mock for retrofit API. Do you have any questions to that part?
For the, you are using the core?
Please louder.
Sorry? Okay. Is it good now?
It is good.
Yeah, nice. And you are using coroutines in the when, but it shouldn't be inside the given. You know, the condition shouldn't be go to the given part. Every coroutine goes to the given part, and only the fetch part in the when.
Where which condition should be? Sorry.
You say coEvery get by and then returns new response. It is something like given data.
Yeah, this is very similar to this if-else call. So on every function invocation, get by Tesla, it returns fake articles.
So it isn't your given. You know, you have given, when, and then.
Okay, so we are asking if this should be in given
Yes.
or when, yeah?
Then inside the when, you have only create use case.
Okay, so our given when then structure could become that given articles for query Tesla exists when some kind of action, fetch data, and then.
Yeah, exactly.
Yeah, that should be much more readable. Thank you.
Thank you. May I ask another question? May I ask another question?
Yeah, sure. Go on.
Okay. Now I see only one test. If we want to have more than one test in one class, how it should be, the naming and...
If I want to have more when blocks,
No, for example, the usual unit test you have, there is a name for each function. For example, if you want to test view model, repository, interactor, you have multiple functions to test. How do you name them? You put everything inside the class.
okay, that means that everything is inside this behavior test class?
Exactly. If you want to write another test, for example, for the same class, how do you write it?
Okay. I would copy paste, I would create other given block. Articles for query, Twitter, not exists. I can have many given blocks in that particular test class. So let's take a look how it looks like. This is first given, this is the second given.
Okay.
Have I answered your question? Because I'm not sure.
Yeah. Thank you. Thank you. Thank you very much.
Thank you. Okay, so let's implement very fast the second test case. Given articles for query Twitter not exists. Okay. CO every Twitter returns. Okay, it may throws exception. So this is other behavior for MockK. Function can return something or can throw exception. Just very generic exception. When I fetch data, then, okay, let's return empty list. Should be empty, and don't update data in database. Okay, so verify exactly 0 times, database update any. Let's run this test, and we'll probably need to adjust our implementation. Okay, and we have this exception. This exception was not handled at all. It is red error. Yellow errors means that assertion failed. Red error means that exception was actually thrown inside our test. Okay, so now this retrofit API throws exception, and in that case we want to return empty list. Okay, so we can do simple try catch, for example. Try catch with this map. It equals try catch an exception. Empty list of article entity. Let's run test again. And our one test still fails because we want to have behavior that when there's empty list, we don't update any data in database. But it could be delegated to this inside implementation, or we can say additionally, if it is not empty, then update. But to be honest, it doesn't really matter. We want to have green tests. Okay, and we have green tests. Any questions so far? Coverage? I don't have a coverage plugin defined here, but in general, Kotest gives you JUnit 5 reports, so it should be integrated into Yakoko or whatever tool you use. I integrated Kotest tests with coverage a few years ago, and I didn't touch that configuration from that time, so I won't tell you for sure how to configure it now, but it is possible. Your continuous integration doesn't require any additional plugins because Kotest is backed by JUnit 5 engine. So this is for Android projects. We additionally need to have that line of configuration to have JUnit 5 properly enabled. And this is dependency for Kotest runner for JUnit 5. So everything is happening inside Gradle and JUnit environment.
Can you switch the order of the method given when then? Can you put when, if it makes sense, for example, to group by all to a method? Can you say when this method is called, given these opportunities?
I think with this framework, let's check this. Class horrible BDD. Let's say this is behavior spec. I guess you can't do that. When? You can't do that because you can create when block only inside given block. Let's take a look. This is extension. And this is defined on behavior spec given container scope. So you can create this only inside given. And the similar is for then. But there is end. There should be end. Yeah. So you can have one more layer of this test grouping. So you can provide additional context for this. Let's run this. And here, we have given when, then, and something, something. And given something, and other thing. Okay, so end block. So when block also accepts end. And you can have many of those. Okay, so one important thing to remember with this behavior specs, you can share configuration between test cases. So we are using the same in-memory database in this test and in this test. Under the hood, JUnit flattens everything and its linear path, okay? And given articles for query Tesla exist when fetch data, then return an empty list. This is first test. The second test is given articles for query Tesla exists when fetch data, then update data in database. In our reports, it looks like there are actually nested test cases, but you can tweak this configuration a little bit. So for the test purpose, let's create some kind of object. It could be any. Okay. And in every then call, we will print this any to check which instance of the object we are dealing with. So this is something assault. Okay. This is first something, this is second something. Let's run this and let's see what is the default behavior for it. Okay, this is the same. This is the same instance. And now we can change this configuration. It is called isolation mode in Kotest, and we can return isolation mode instance per leaf, instance per test. So let's do instance per test. Let's run this again. And now, this object, this any object defined somewhere in given block has other instance in one then and other instance in second then. Let's check what is default behavior for this isolation mode. Okay, we cannot check that so easily. Okay, but we can configure single instance. So yeah, for every spec initialization, there will be single instance for every test case. We can create instances per test or instances per test case group. So instance per leaf. Let's check instance per leaf. Okay, that was instance per leaf. And single instance. And single instance, it looks like this default behavior for behavior spec. Okay, so that was a few ways to isolate your tests. And it depends what you actually need to do. Do you need your test to be performant, or do you need to avoid shared mutable state at any cost? Okay, it's for unit test that milliseconds performance shouldn't be an issue. So I suggest doing instance per test. And I wish that was default behavior in Kotest. But unfortunately, as we learned, it isn't. Okay, any questions for that part? Before, after, like in JUnit? Yes, it provides, but my question for you is, why would you use that? Okay, so one case for before, after is setting up mocks. As you were doing in Mockito, Java style, there was a huge before block with all the mocks configuration, and in particular tests, you were creating mocks. You are creating behavior for that particular mocks. But since you are doing here everything from code, not from annotations, you can create those configurations in here, in code, in this huge Lambda. And if you actually want to, have this behavior for before, after, you can extend functions before any, before container, before each, before spec, before test, and what is else? Some other before test. They're not the same? No, because this is suspend. Okay, so you should probably run on your own every this before after cases to see how would you benefit from calling those functions. But if you can configure everything inside this DSL, it should be enough. Okay. Let's do the model. So let's see what is happening here. To this vModel, we are passing some news ID, and we have use case that is fetching data. This use case may return some item or throw exception. And additionally, we have some kind of mapper. Okay, but this vModel, there are no coroutines. So let's take a look at news list vModel. That is actually here. Okay. So let's very quickly create test for that. Again, remove this internal, I don't need that. And let's do free spec for starters. Okay, vModel. Split right, create vModel, helper function, equals news list vModel. Where this fetch news use case equals fetch news use case. Mapper equals mapper. And initial query equals Tesla. Okay, let's put it with one more mock for resolve default query. For that case, okay, we already have this, but we can create MockK very quickly for this. MockK every fetch default query returns initial query. Let's change it to Twitter so we don't have collision with real implementation. Okay. So what is happening in this vModel? We have fetch news use case, and we have some state. And we will be observing this state. Where is init block in here? Okay, we are launching something in here, so let's check that. It should fetch data. Okay, we'll change this later. Let's create this vModel. MockK. And fetch data returns 11 fake articles. Okay. Val vModel equals, and we have vModel state.value. Let's print this. And let's see what is happening in here. it should fetch data. And it actually printed us some kind of screen. Unfortunately, without any elements and with loading set to true. Okay. So what should we do here? View model scope.
We should inject test scope so that coroutines run in test scope, right?
Okay, should we do it right now? Inject everything?
So the way normally I do it, I know about this, that you inject, for example, coroutine context into your model, and then you attach this context to the model scope.
Exactly. I should have already interface for that. Okay, because what I'm doing here is I'm creating abstraction over those dispatchers. It's coroutine dispatcher. And it's coroutine dispatcher. Dispatchers.io, and in here we have dispatchers main. Or do we have Android dispatchers? No, okay, just dispatchers main, that should be fine. In our view model scope, we have, okay, we have already this. So, nice. So now we are injecting this dispatcher facade to our view model. Of type dispatcher facade. And this is why I like creating additional functions for test, builder functions. So we don't change everywhere in our test that behavior. We don't change that function, we change only code in here. So this dispatcher facade, let's create test dispatcher facade. And how should we implement it? Unconfined or test dispatcher unconfined? Okay, let's try this. So we will pass that coroutine dispatcher. And we can create test dispatcher facade with this dispatcher, first and second, yeah? Is it okay? Okay, and one more thing to do is to update, okay, in here we need dispatcher test scope dispatcher, something like that. Do you remember? Okay. Please louder. No? Or we can just use standard test dispatcher here. okay, which is experimental, and previous test dispatcher is deprecated. So that's a fun fact. Okay, so now let's plug this in here, dispatchers.io. And somewhere else? I don't think so. Okay. Okay, we need to update coin configuration, single of type dispatcher facade, Android dispatcher facade. Oh, it's much better than Dagger. Okay, and what do we have in here? Still no elements. Why?
I think you have to advance until idle as we call a standing function.
Exactly. We can do it on standard test dispatcher with some advance, schedule and advance, something like that, but we can also use unconfined test dispatcher, which should run all the code immediately. What do we have in here? Page displayable should not be empty. Let's run this. It's still empty. Why? We have some state. Let's do something else. View model, state, test. And now we can treat the state flow as flow. And what happened here? First element came. First element is in here, the second element. There is no second element, no value produced. Okay. It's not as I expected. Sorry. Let's do something like this. Oh, yeah, or I can actually open project where it's working. And this is list test. Okay. So this is new test. This is other test for the same class, and I will try to explain line by line what is happening here. Okay. Same as in our previous test, I added dispatcher facade, which is abstraction for coroutine dispatchers. Next, I am defining fetch news use case with MockK. Fine. I am creating displayable mapper. Okay. I am mocking this default search query use case. Okay, and now we have fun part. Because there are a lot of configurations each time with state flow configuration, I actually created an abstraction for it, and it's called ViewRobot. ViewRobot, in terms of front end, you can think of it as page object pattern, something like that. State ViewRobot is a generic robot that will accept some kind of data and will translate data coming into this flow. It will add it to the list of states. And what I'm doing here is I'm telling robot.collect this data, add to the list of states, and perform assertion. Let's run this and let's try to break it. Okay, it's not compiling. Nice. Or maybe we can copy-paste this to this project. Okay, so we have that kind of state flow turbine, ViewRobot extract from current file. Okay. We need some coroutine scope, empty coroutine context, test coroutine scheduler, state flow, and extension on state flow test in this particular scope. This is from library turbine. Okay. So now, in our test, I am creating this ViewRobot. ViewRobot for which type? For that type. Okay. It actually got this. Let's change the standard. And now, ViewRobot.collect. Let's remove this. And let's print list of states. Okay, let me look at this previous view model. And yeah, this is from the previous project. So now we can check what is happening here. Behavior spec defined with Kotest, standard test dispatcher for all tests, initial query Tesla, create test dispatcher, create mock for fetch news use case, mock for suspend function with CO every, real implementation of displayable mapper, mock implementation for use case. Let's create ViewRobot, which is abstraction for state flow that is inside our view model. We are on start, we are calling, hey robot, collect some data. And this data, okay, scheduler advance until idle. That was what you said before about advancing time in those coroutine schedulers. This is in test coroutine scheduler, which is abstract class. Not exactly, okay. We can advance until idle. This robot is collecting states and putting these states into the list. So first state is that we updated this search query. Okay, when we have some kind of error, we are on this view robot calling 2 times collect for first state, for second state, and then we are doing assertion for first state and assertion for second state. And with this pattern, we can make assertion on the whole list of states that our view model was in. Loading, error, rerun current search, change query. We can have assertion for every step. Maybe do you have questions for that part? I guess you may have some questions because it's not so straightforward, but this view robot pattern is actually quite nice. Exactly, and it was, for me, much easier with Eric's Java. Yeah, it's counterintuitive in this Android example because we have not regular flow, but state flow, which is like behavior subject in Eric's Java, I think, something like that. And we have many coroutine contexts in here. We are using this view model scope, which under the hood has also reference to main dispatcher, to main thread. And sometimes we need to additionally mock this we may need to additionally mock this dispatcher's main in our test code. So it's not so obvious. And last time I checked in this repository for Turbine, there was no example for state flows. So even the authors of that library are not sure how to properly check how state flow should behave in tests. Please repeat. Yeah. Well, injecting these dispatchers is actually quite nice and solves many issues. But once you're using this view model scope, which is just auto-closable for some coroutine context. So that's the only benefit of using the view model scope is to clear the scope in closable coroutine context once view model is closing. And that's the suggestion to mock statically the whole main dispatcher, which is, it's not inversion of control, it's injecting some magic. I don't know why, but it works. So.
The point is that in production I assign a dispatcher this coroutine context because the dispatcher is also a coroutine context. But in test I can just get the test coroutine context, and the test coroutine context also has the standard test dispatcher assigned. So the coroutine does a lot of magic, so you can extract this, and this works in test and this works in production, correct? But this is, I think, you can nowhere find a really definitive guide how it should be done. So you find a method that works for you, you should stick to it. I can show you later how we do it if you're interested.
Okay, so this ViewRobot pattern, I am writing article about that, so I'd be happy if you could review it, maybe sometime in this month. So it would be nice because it's really hard. And yeah, I hope you had a good time on this workshop. Repository should be available still here on my website, so you can check all the code and try to break it yourself. Thank you.